Kai. I'm the product manager here at Kubecost, and I'm going to walk you through some of the most important or most impactful features we have at Kubecost, and hopefully give you an overview of the value we're delivering to our customers. To start, we'll kind of dive into the Kubecost Allocations page. So this is really kind of the bread and butter of Kubecost here. This is how users or teams are able to understand the cost of the workloads that they're running in Kubernetes. So you can see here by default, we have it aggregated by namespace. So these are the namespaces I have. And keep in mind, this is going to be multi-cluster and multi-cloud and hybrid cloud, in fact. So all the clusters I have, regardless of what cloud provider they're coming from, or even if they're on-prem clusters, I can see the cost for all of those clusters right here, all together on this one single pane of glass. So we have this broken down by namespace here, but of course I can drill in. Let's say I want to drill into my Acme Fitness namespace, and here I'm now looking at controllers in that namespace. Maybe I can drill into a controller here, and now I'm looking all the way at the pods. And then finally, I can drill into pods and see the cost for each individual container. So I think this is a good opportunity to talk a little bit about how Kubecost works. So Kubecost is going to monitor your usage in real time. So you can see here we're monitoring. We can see that this container is using this many CPU, this much RAM. And then we use the publicly available cloud provider APIs to estimate the cost associated with that usage. So in that way, we're able to deliver real-time cost visibility to our users. And then what we do is, if you integrate with your cloud provider, we're able to see any discounts if you have like EDP agreements, or if you're taking advantage of savings plans, RIs. We're able to see what you actually paid for this usage and make the adjustments that you can see here. So in this way, the costs you see in Kubecost are going to match what you're paying on your credit card bill. So you kind of get both benefits in terms of real-time cost monitoring, as well as the accurate costs you get from reconciling your costs or your spend against your bill. So we'll come back here to namespace level. So you'll also notice just some maybe fairly obvious things. You can slice and dice this however you want. So if you wanted to look at custom labels here, we can do that. You can say, okay, I want to filter to where app is Acme Fitness, right? Or you can filter based on app is not or contains Acme Fitness. So we really give you a bunch of ways to kind of slice and dice this data. And then of course you can save a report. So maybe I'll come back, I'll do custom label app is Acme Fit, right? And then I can save this report and say, Acme Fit spend. So now I have this report saved, and whenever I need to come back, I can come back and see my Acme Fit spend right here. There's some additional settings as well here. So you'll notice that we have idle costs. So right now there's a bunch of ways that you can handle as a user idle costs. So you can have them separated out. So for instance, if I drilled into Acme Fitness again, I can see the idle costs as its own line item, right? I can see how much I'm paying in just the Acme Fitness namespace for resources which are not being used. So you can see that there as its own line item, or you can kind of share this idle costs to the workloads, by cluster or by node. So if it's by cluster, right, it'll share those idle costs with the other workloads on that cluster. If it's by node, same thing, just by node. You can also do things, like look at rate costs instead of cumulative costs. And you can also share some individual namespaces as well. So let's say, I want to share the Kube system namespace, right? That's like, a namespace that's just kind of foundational and required to run Kubernetes. So I can share that cost. the kube system namespace will disappear from the table, and it will be, included in this shared cost column now, distributed across all the other namespaces or workloads. So this is, again, the kind of core or bread and butter of Kubecost, where you can get the costs for all of your Kubernetes workloads. And you'll notice, the costs are broken out by the different resources, so CPU, GPU, RAM, volume, network, load balancers, et cetera, et cetera. And you can also see the carbon costs. So this is in kilograms of carbon. So if you want to go beyond just dollars and cents costs and see, the carbon impact of these different workloads, you can see that as well. So moving beyond allocations, right, we also have this assets page. It's going to be very similar. I kind of think of it as the other side of the same coin. So this assets page, instead of looking at the workloads running on Kubernetes, this is going to be a view of like the hardware, if you will, that's running those Kubernetes workloads. So you can see, we break it out by like node. So here are your different nodes that you're paying for. You can see the tags on them. And, load balancer, disk, network. So this is really kind of broken down by, assets, asset type, or the physical things that you're paying for to run these Kubernetes workloads. Okay, next we have the cloud cost page. So, as I mentioned earlier, you can integrate your cloud provider or CUR, if you will, into Kubecost. So that allows us to not only reconcile the costs so that they match your bill, but we also will just pull in your cloud bill and show it to you in this Cloud Cost Explorer. So again, you'll notice here, if I aggregate by provider, right, I have the cost coming from AWS and Azure. We can add in GCP as well. So again, you can get the cloud cost for all your cloud providers here in one pane of glass. And our aggregation and filter fields are going to be according to the focus spec, which was developed by the FinOps Foundation. So these, the fields coming out of your cloud bill are going to be mapped to, a common set of aggregation and filter options according to the focus spec. But yeah, this really allows you to, okay, if I want to understand my, EC2 spend, I can drill in, see the cost for each of my individual EC2 instances, right? And get all of your cloud costs together, again, in a single pane of glass. This page is going to give you a nice overview of all of your clusters, right? So you can see, okay, I have these clusters. Green means actively being monitored by Kubecost, right? I can kind of drill into it and get an overview of the cluster. Everything that's happening here. Again, it's assets, it's namespaces or workloads, it's efficiency, it's trends, etc. So this is kind of a nice overview of all the clusters, and you can see diagnostics here as well on these clusters, to make sure that the Kubecost agent that's installed on the cluster is healthy. And you'll notice also we have some clusters here with an orange dot, and you may say, okay, well, what are those, right? How do you see this cluster if it's not monitored by Kubecost? Essentially, what these clusters are going to be are clusters that we are seeing in your cloud bill, right? Because you've integrated your bill into Kubecost. So these are clusters we're seeing in your bill, but do not have a Kubecost agent installed. So these clusters would not be represented on, say, the allocations page, right? Because we don't have the agent, we don't have the data coming in for these clusters. But this is kind of a nice way for teams to ensure, right, that they have the Kubecost agent installed on all their clusters across their estate. Moving on, we have this external cost page as well. So this is actually built on OpenCost plugins. So I'll kind of pull that up really quickly. So if you're familiar, OpenCost plugins are basically, it's a plugin framework that allows you to see your kind of other IT costs all together in Kubecost. So today we have support for Datadog, MongoDB, Atlas, and OpenAI. I don't have OpenAI integrated into this demo environment, but rest assured that plugin exists. And you can we have this plugin framework which allows you to view the cost for these external IT resources, all together, right? And more to the point, right alongside your cloud costs and Kubernetes costs, right? So again, you can kind of drill in here and see, what is specifically, driving these Datadog costs in this example. And once again, similar to the cloud cost page, our aggregation and filter options are going to be focus spec compliant. So we map all these fields, or we map the fields coming out of, let's say, the Datadog or MongoDB billing APIs. We map those to focus spec fields. And yeah, I mean, this is an open cost, which is an open source technology, and we really encourage, if there's another IT tool that you use and want to have those costs running into Kubecost, right? We encourage contributions. It's really quick and easy to add additional plugins. I think we've had community members, I think, have contributed, like OpenAI and MongoDB, in less than a day. So really easy, and just we're really excited to work with the community to build out a whole suite of these plugins. We also have this efficiency page, which has been really, really powerful for a lot of our teams. This page, I like to think of it as, show me my waste, right? In general, cloud spend is always kind of increasing, right? Your applications are growing in complexity. Your user base is expanding, hopefully, right? So your cloud spend is always kind of growing and growing. I would say that's kind of fairly standard. I think, fairly advanced organizations are happy with just, keeping it flat, right? But this is a dashboard just showing you your idle costs over time. So I think teams that are really running effective FinOps strategies are really going to see this kind of decrease or stay constant over time. I think for a lot of our, advanced FinOps teams, they're using this as a KPI. Or key performance indicator or goal to keep this idle costs consistent or going down over time. Kubecost breaks idle down across two dimensions. So we have workload idle. This is going to be the cost of resources which are requested but not used. And you also have infrastructure idle, or infra idle, which is the cost of hardware resources which are neither requested nor used, right? So we break it down on two dimensions because typically, a given optimization solution is really going to target, one idle dimension or another. So for example, like a carpenter is going to target infrastructure idle, right? Like if a node has a bunch of extra capacity, it's going to, provision a smaller node, right? But workload idle, this is really where you want to right size your container requests, right? If you have high workload idle, that kind of means, I'm requesting, or I have a bunch of containers that are requesting a bunch more resources than they're actually using. Carpenter doesn't really get into that world. That's where you're looking at other tools to help, like Kubecost, which can help reduce your workload idle. And then the final kind of monitor dashboard Kubecost has is this network monitoring dashboard. So here you can, I think for a lot of our customers, one of the things we've heard is, our network spend is a total black box. And, we really, network spend can be a significant portion of our spend too, and we really want to understand where that money is going. So the goal of this page is to really just show you your network spend kind of at a glance. And this page does require installation of our network cost daemon set. So that's obviously a daemon set that's going to be installed on each node. It's going to see the network traffic coming right off the kernel, and it's going to kind of infer the cost based on the publicly available cloud APIs and show you, again, what is driving your network spend, right? Maybe it's this Kubecost namespace. Okay, what is it communicating with, right? We can see it's sending a lot of traffic to EC2 and maybe sending and receiving a lot of traffic from S3. So you can kind of get all of this at a nice glance. Awesome. So just continuing here, we also have this concept of Kubecost collections. So this is a new thing that introduced in Kubecost 2.0. It's been really powerful for our teams. The problem we're trying to solve with this feature is, a lot of organizations want, we have this kind of allocations dashboard, we have the cloud cost dashboard, but I want to understand the costs for a given, team, application, or business unit. I want to understand those costs all together, right? I want, you know, if I have a database, I want to understand that the database cost right next to my Kubernetes cost. So this is kind of what we have created to allow you to do that. So let's say I want to understand the cost for my demo application, right? I can, you know, simply see, okay, I'm going to add in the cost for the Acme Fitness namespace, but I'm also going to add in the costs for, you know, cloud costs wherever, you know, cost center is engineering. So you can add in the costs, you know, across however you want, right? So maybe I want to add in, you know, all of my, you know, EKS costs, or, you know, let me pick something maybe a little more logical. Maybe it's responsible, this application, for all the CloudWatch costs for some reason, right? I can just hit add, it'll be added here. And then what Kubecost will automatically do for you is subtract any overlapping costs. So it's possible, right? I added, let's say, a namespace, let's say the Acme Fitness namespace, but I also added like all the EC2 costs that exist. Well, it's possible that, you know, some of the Acme Fitness cost, right, is the EC2 or node costs that I've already added here as well. So we don't want to double count those costs for you, so we subtract any overlapping costs. So the cost you see here is like the grand total for this, you know, business unit. In this case, it's the demo app. So that's a little bit about collections, really powerful feature to kind of combine your Kubernetes and cloud spend and get, you know, one report for your business unit. So diving into some of the optimizations Kubecost can do for you, you know, you see here we have a whole bunch of savings insights. I'll kind of focus on the most popular ones or the most impactful ones here. So I'm going to start with container right sizing. So again, we see all the time, we see organizations who save significant money by just right sizing their container requests. And it's understandable, right? Your developers want to make sure their application runs. They don't really have a great sense of how much resources that application is going to need, so they kind of intentionally over provision it to ensure the application runs. So if you don't have some sort of a tool that helps you come back in and right size those container requests, you know, you're going to have a lot of wasted spend in your cloud environment. So you see here, right, we have the Kubecost recommendations. You can see for a given container, let's look at this one. We can see the average usage, right, for RAM or CPU. You can see the max usage, and then you can see, you know, the current request and the recommended request as well. And so based on, you know, if you implemented these recommendations from Kubecost, you can see the monthly savings or estimated monthly savings associated with implementing those recommendations. And you can totally customize the Kubecost requests here, or excuse me, the Kubecost recommendations here. So right now we're looking at production, but maybe I want to say, okay, this is, you know, I'm going to do some filtering and I'm going to look at development profile. Well, that updates the target utilization to 0.8 instead of 0.65, which 0.8 target utilization, I like to flip it and think of like, okay, that's going to add a 20% buffer, right? So in development, maybe you're okay with a 20% buffer, but if you're going to go to HA, you're going to set target utilization to 0.5 to give yourself a 50% buffer. So totally configurable how our recommendations will work. You can click save, and you can see here now I have more estimated savings available for this container because I'm recommending, or Kubecost is recommending a you know, requesting less resources. So. And in fact, you can, if you don't want to manually implement Kubecost recommendations, you can leverage Kubecost actions. So you can basically set up, you know, automatic recommendations, and then Kubecost will go in and implement these recommendations for you on, you know, on a configurable cadence. So we can go in every hour or day and automatically resize these container requests so that you kind of get those savings on autopilot. So there's a bunch of other insights here. I think one other one that we're excited about, this is a new one, is GPU optimization. I don't have any GPU nodes in this demo environment, but that's another really impactful one. You can also look at the workloads which have been abandoned, right? These are all the workloads which are, have network traffic below X, and of course you can configure that over the last configurable time frame. So these are just kind of workloads which are maybe eligible for cleaning up, right? Because they're receiving traffic below some threshold. And orphaned resources as well, right? Here are disks or IP addresses that are not being used anymore. We recommend these are probably candidates for deletion. So a lot of stuff like that to just help you optimize your cloud environment and reduce wasted spend. Finally, I think the last piece I'll cover here is our governance piece. So really, a lot of teams, once you've kind of gone past, we look at it as like crawl, walk, run. So crawl is really monitor, being able to run chargeback, showback, and get a handle on understanding what each of your business units are costing you. Walk is maybe optimizing your cloud spend, so implementing maybe some of the savings recommendations or implementing some of our savings automation. And then finally, run. At this point, you have a handle on your cloud spend, you feel it's optimized, and you want to implement a budget or some governance to ensure that your cloud spend remains efficient. So really easy to create a budget here. You can come in and say, create a budget. You can create a budget based on some allocations filters, assets filters, cloud, or collections. So if I think about the collections I created earlier, we were looking at demo app. Right, I can say, okay, I don't want demo app to cost me more than, I don't know, let's say $5,000 a month. So we can say it's going to be a monthly budget that resets on the 1st. And then you can set budget actions, right? So maybe I want, when we reach 75% of the budget, I'm going to get an email. Do this. Maybe, and then maybe I'll save this action, and then maybe at 100% of spend, it should, be this alert should be escalated to, my boss. So we'll do, web at IBM. So you can kind of configure these actions based on different thresholds, right? We do email, Slack, Teams, whatever you like. And these budgets, actually, you can also integrate. We have a blog post up about how to do this. You can integrate Kubecost budgets with a policy engine like Kyverno to actually enforce the budgets and prevent overages. So this will kind of, it's kind of a Kubecost prediction API and Kyverno integration where, if a change, maybe some new deployment or change to an existing deployment, if Kubecost Predict API predicts that you're going to go over that budget by making that change, it will block that change from happening, all in the CLI. So pretty cool tool, just depending on how mature your FinOps organization is, if you can set budgets and really start to enforce them. So you can kind of save this budget. You can see that there. So that's a quick overview of kind of the core, pieces of Kubecost. But if you have any questions, feel free to reach out to me personally. My name is Kai, and my email would be kaiwambacher@ibm.com. So feel free to hit me up if you have any questions at all.